Hello, algebra students. Today's lesson is on 3.1 functions. We'll be looking at the questions. What is a function and how are they represented as ordered pairs, graphs, tables, and mapping diagrams? And the learning target for today is I can identify functions. So before we begin, we have some important vocab today. A relation is a set of ordered pairs. So when we're looking at relations, we're going to be looking to see if they are a function, but any set of ordered pairs can be a relation. Next, we have a function. A function is a relation that pairs one input with exactly one output. Outputs can repeat, inputs cannot. We'll look at those in our examples. The domain is the set of x values. Domain can be discrete or continuous. Discrete is going to be a list of numbers, and continuous is going to be represented as a compound inequality. And lastly, the range is the set of y values. This can again be discrete or continuous. Discrete is going to be a list of numbers. Continuous will be an inequality. All right, here are some examples of how functions can be represented. First off, they can be represented by an equation. We're going to see these in the form y equals mx plus b. In this case, we have y equals negative 2x plus 8. Those are the dots on the graph. It can also be represented as an input-output table. We're also going to call those an xy table. So if I plug in 0, 1, 2 for x, if I plug in 0 for x, I get y equals 8. If I plug in 1 for x, I get y equals 6. And if I plug in 2 for x, I get y equals 4. We can also describe a function using words. How would we do this? Well, on the y-axis, x is 0, y is 8. Looks like the graph goes down by 2, and it looks to be linear. All right, we can also describe them by a graph. That's what's pictured on the right. And then a set of ordered pairs. So if I were to list out all the points on this graph, I would have 0, 8, 1, 6, 2, 4, 3, 2, and 4, 0. Okay, part A, explain why the graph shown represents a function. There is one input for every output. And x does not repeat. Again, if x repeats, it's not a function. All right, example 1, determine whether each relation is a function. Explain why or why not. So when we're looking at relations, to decide if it's a function or not, we're looking to see if x repeats. Remember, the definition of a function is there's exactly one output for every input. That means your inputs cannot have multiple outputs. So we're going to look at the x values in A. I see negative 2, negative 1, 0, 1, 2. X does not repeat. Yes, it's a function. Now we look at example B, and I have 4, 8, 6, 4, 5. So I see 2 ordered pairs with a 4, and they have different y values. So there are multiple outputs for this input. So no, this is not a function. All right, part C is an input-output table. So I'm looking to see if x repeats, and I see 2 values with 0 here, and there are separate outputs. You cannot have multiple outputs for one input, so this is not a function. And then part D, we have an input-output table. There is exactly one output for each input. Notice there are 2 arrows going to 15. That's okay. Y can repeat, x cannot. So yes, this is a function because there's only one arrow starting at each input. All right, another way to determine if a relation is a function is by the vertical line test. So when a graph represents a function, if no vertical line passes through more than one point on the graph, then it is a function. So notice in the first example, that red dashed line, if you imagine that vertical line anywhere on the function, it's not going to cross. It's not going to cross it more than once. So the first one is a function, but notice on the second one, that dashed red line crosses the relation. The blue line is the relation. It crosses it twice in one point, so that one is not a function. All right, let's try this out. In part A, we imagine a vertical line, and it crosses the function twice there and twice there. So part A is not a function. These are the inputs on the x-axis. So for the input 2, there are multiple outputs. There's the output 2 and the output 5. Not a function. All right, and then part B, if I imagine a vertical line anywhere on this graph, it's only going to cross it once, which is exactly what we want. Yes, B is a function. All right, for example 3, we're going to be looking at the domain and range. Remember, the domain is the set of input values, or the x values, and range is the set of output values, or the y values. They can also be continuous or discrete. Remember, discrete is when it's just listed out, and continuous is when we use an inequality. So when we're looking at part A, this is going to be discrete data because they're ordered pairs. It's listed. So let's list out our ordered pairs. We have -3, -2, -1, 0, 1, 2, and 3, 4. The domain is the set of all x values, so the domain is -3, -1, 1, 3. And the range is the set of all y values, so the range is -2, 0, 2, 4. All right, part B is a little bit trickier because it's continuous data, which means we're going to represent it as an inequality. So the domain is the x values. It looks like on the x-axis it starts here and ends here. So we're going to write that as -2 is less than or equal to x, which is less than or equal to 3. I say or equal to because both of the points are shaded in. If those were open, it would not have an or equal to sign under it. Remember, or equal to includes the number. We learned that in chapter 2. And x is in the middle because it is a compound inequality. As long as you write it as less than values, you can just read it left to right. -2 is less than or equal to x, which is less than or equal to 3. All right, that was our domain. And our range is the y values. It looks like y ends here and starts here. So we're going to say -1 is less than or equal to y, which is less than or equal to 2. And part C and D are continuations of the last example, so we're still finding domain and range. C is discrete data, so we can just list it out. The domain, I'll list the x values. It looks like I have -2, -1, 0, 1, 2. And the range is the y values, so I'll list those out. I have 4, 2, 0. And then 2 and 4 repeat, so I don't need to write them again. All right, and then D is continuous. Because continuous is a little bit trickier, I encourage you to pause the video, see if you can get it by yourself, and then check to see if you got it right. So domain is x. X starts here and ends here. So we're going to say 1 is less than or equal to x, which is less than or equal to 5. And then the range starts here, ends here. So 0 is less than or equal to y, which is less than or equal to 4. Again, it's or equal to because the points are colored in. All right, for the next section, you're going to hear some vocab you might have heard in science class before. We have the independent variable, which is the x value, and we have the dependent variable, which is the y value. The y value depends on what you put in for x. X is the input, y is the output. All right, so example 4, problem solving. The function y equals -3x plus 12 represents the amount, y, in fluid ounces, of juice remaining in a bottle after you take x gulps. Identify the independent and dependent variables. Well, the amount of juice remaining depends on how many gulps you take. So x gulps is independent. I'm going to say independent is gulps, or x. And then the dependent variable is the amount of juice left, or y. All right, the domain is 0, 1, 2, 3, 4. What is the range? To find this, we're going to set up an XY table. And as we look at the domain, you can tell that it's discrete. Now I want you to pause the video for a second and think, why is this discrete? And now I'll give you the answer. It's discrete because the x values are listed out. Why are they listed out? Well, think of what we're measuring. We're measuring the amount of juice left after x gulps. You can't take a half of a gulp or an infinite decimal amount of gulps. It's either 0, 1, 2, 3, or 4. So let's continue this XY table. We have 0, 1, 2, 3, 4 for x. So when I plug in 0 for x, again, I'm looking at the function up here. When I plug in 0 for x, I have 12. Now think again, what does that mean? That means we start with 12 ounces of juice. After I take one gulp, 12 minus 3 is 9. 2 gulps, I'll have 6 ounces left. 3 gulps, I'll have 3 ounces left. And 4 gulps, I'll have 0 ounces left. So also think, how many gulps did it take to finish the juice? It took 4 gulps to finish all 12 ounces of juice. And what is the range? Well, these values are the range, or we could write out the range is 12, 9, 6, 3, 0. Again, it's discrete because the domain was discrete because you can't have decimal values in this. It's not continuous. It's listed out. All right, let's wrap it up with some summary questions. What is a function? Look back at the vocab on the first page. A function is a relation where each input is paired with exactly one output. What other words can you use to describe the x value of a function? The x value is the domain or the independent variable or the input. So we have 4 ways to describe x. X, input, independent variable, domain. What other words can you use to describe the y value of a function? We have output, range, and dependent variable. How can you identify functions? In ordered pairs or an input-output table, we look to see if the x values repeat. You can't have an input repeated with multiple outputs. On a graph, we can do the vertical line test. How does the vertical line test help identify a function? Well, if you imagine vertical lines and it crosses the function more than once on a graph, it's not a function.